Our study today is about sequences. What is a sequence? A sequence is a pattern of numbers that are related by a relation. So it's a consecutive numbers. For example, here we can start by u0, u1, u2, u3, etc., such that the terms are related to each others by a relation. For example, if you start by u0, u0 will be the first term, u1 will be the second term, u3 the third, u2 will be the third term, u3 will be the fourth term. If you want the 10th term, because I'm starting with u0, it will be u9. Sequence, we say sequence un between parentheses, it means sequence un. And un alone, if you don't have parentheses, it is called the general term of the sequence. Or you may start by u1, u2, u3, u4. So u1 is the first term, u2 is the second term, etc., etc. If you want the 10th term, it will be u10. So n is always an integer which is positive, or it can be equal to 0. For example, if you want to write a general form of a sequence, an infinite sequence, if you start by u0, u1, u2, up till you have un, the term before un is un minus 1. The term before un minus 1 is un minus 2. The term after un is un plus 1. And after un plus 1 is un plus 2. 3 points, it means we have an infinite sequence. We have two types of a sequence. Explicit sequence. Explicit sequence is a relation between un and n. Let us take an example. In this case, we can find any term we want directly without finding all terms before. What does it mean? Consider the sequence un defined by un equal n squared minus n minus 1, where n, the first term, is 0. Why? Because n bigger or equal to 0. Find the first four terms. So if I want to find the first term, I do u0. I replace x by 0 here. It will be 0 minus 0 minus 1. So the first term is u1. If I want the second term, it will be u1. I replace n by 1 here. So 1 minus 1 minus 1, it is minus 1. The third term is u2. u2 because is the third term because the first term is u0. So u2, the third term, will be 2 squared minus 2 minus 1 is 1. And the fourth term, it will be u3, 9 minus 3, 6, 6 minus 1, 5. If I want to find the 10th term, I do u9 because the first term is u0. So I replace n by 9, you're going to get 71. If I want the 16th term is u15, so 15 squared minus 15 minus 1, you get that number. So as you can realize, in explicit sequence, you can find any term directly without finding all terms before. And I mean, if you want to find u15, no need to find all terms from u0 till u14. You can find it directly by replacing n. Another example here, it's a sequence un equal n minus 2 over n plus 1, where n bigger or equal to 1. So the first term here is u1. Find the first 5 terms. The first term is u1, so 1 minus 2 over 1 plus 1 is minus half. The second term, it will be 0 because 2 minus 2 is 0. The third term is 3 minus 2, 1 over 4. The fourth term, it will be 2 over 5. If you want to find the ninth term, because the first term is u1, it's simply u9. So 9 minus 2 is 7 over 9 plus 1, 10. And the 15th term, 15 minus 2, 13 over 16. So the form of explicit, it's always you can find any terms you want directly. It's a relation between n and un and n. هلا recursive, it's a relation between two consecutive terms or sometimes more. So here in recursive, if you want to find any term without, you need to find all terms before. Contrary to the explicit, you need to find all terms before. Given a sequence where the first term u0 is 2, the question here is you want to find un plus 1. Okay, un plus 1, sorry, equal to un minus 3. What does it mean, un plus 1 and un? Un plus 1, it means any term equal twice the term before in this example. And un, first of all, we have un. After un, what do we have? Un plus 1. So un plus 1 equal, in this example, twice the term before minus 3. So that's why here, if you want to, you have u0 is 2 the first term. The second term is u1. So here, if you want to put u1, it's 2u0 minus 3, because before u1 you have u0, or you can take n to be 0. So u1, 0 plus 1 is 1. You replace here n by 0. So 2u0 minus 3. 2 times 2 minus 3 is 1. If you want to find u2 here, it will be 2u1 minus 3, because the term before u2 is u1. Or you replace n by 1. 1 plus 1, 2. Here you will be n is 1. So 2u1 minus 3. So since I have now u1, you replace it to get minus 1. If you want to find u3, it's 2u2 minus 3. You have 2u2. So as you can see, if you want to find any term, for example u4, you cannot find u4 if you don't have u3. So that's why you need to find all terms before. Suppose I told you, okay, find u7 or u6. To find u6, what do you need? 2u4, 2u5 minus 3. I don't have u5. So you need to find u5. What do you need to have? To find u6, what do you need? You need to find u5 before. So it will be 2u4 minus 3. So 2u4 minus 3 minus 26, so minus 29. Since now it's minus 29, you can find u6. So if you want to find in recursive, if you want to find any term, you need to find all terms before. In explicit, the previous part, if you can find any term you want, because it's a relation between un and n. Here it's another example. u1 is 2. Find the fourth term. So to find the fourth term, you need to find all terms. So if you have u1 is 2, so u2 what will be here? 2u1 minus 1 over u1 plus 2. So u1 is 2, so it will be 4 minus 1 is 3 over 4. So it's 3 over 4. If you want to find u3, you need u2. Already I have u2, so you replace it. If you want to find u4, you need u3. You just replace it. So recursive, if you want to find any term, you need to find all terms before. Okay? Now we're going to talk about variation of a sequence. Either a sequence is increasing or decreasing. To know, you need to find any terms minus the term before. If it's positive, it means the sequence is increasing. It is decreasing if any term, in general, we're doing it in terms of n. Any term un plus 1 minus the term before. If it's less or equal to 0, it means the sequence is decreasing. Let us take example. I have this sequence. I want to show that this. I want to prove that. I want to show the variation of this sequence. So I do un plus 1 minus un. What's un plus 1? You replace n by n plus 1. It will be 2 parentheses n plus 1 as you can see, over n plus 1 plus 1. Minus un, 2n plus 1 over n plus 1. So 2n plus 2 plus 1, 2n plus 3. If you do same denominator here, 2n plus 3 times n plus 1, minus 2n plus 1 times n plus 2 over this one. After expanding, you can check it by yourself. You're going to get 1 over n plus 1 over n plus 2. We know that n is a positive integer bigger or equal to 0. So 1 over, this is a positive. It means always un plus 1 is bigger than un. You know, the term after bigger than the term before. So it's increasing. Here another example. You want to prove the variation. You do un plus 1 minus un. So it's minus. You replace n by n plus 1. It will be n plus 1 square plus 3 minus un. Here you expand. It will be minus n square minus 2n minus 1 plus 3 plus n square minus 3. You have minus 2n minus 1. N is a positive integer bigger or equal to 0 times negative. So this is the sum is negative plus a negative number. This is always less than 0. What does it mean? It means that the sequence is decreasing. Here another example. You want un plus 1 minus un. It's 2 power. You add to n plus 1 minus 4. Always split. 3 power n plus 1 is equal to 3 power 1 times the 3 power n. Split it. So here what do you get? You get 2 times the 3 is 6 into 3n minus 2 into 3n. What do you get? 4 into 3n. So 4 times 3n is always positive, so it's increasing. If you take this one here, you add the plus 1, you split 3 here, you can put minus 3 into 5 power n into 5. So minus 15 into 5n plus 3